So for today's video, we're going to be upgrading a gun that a customer brought in. This is a Krytac M4. He wants to make it more responsive, a little bit better performance. So we're going to be doing a full upgrade to this gun, which will include adding 12-to-1 gears, a full metal rack piston, a G&G MOSFET. We're going to upgrade the bushings to steel bushings. We're going to add a speed trigger. This takes up some of the gap in the trigger so that the trigger responds quicker. And we're going to be upgrading to a 40K motor. So let's get started. So once I had a chance to break this gearbox all the way down and take a good look at it, I can see that there are some pretty significant differences between a Krytac gearbox and a standard Tokyo Marui gearbox. So there are going to be some compatibility issues. One thing is the way that the MOSFET mounts into the rear of the gearbox. Another thing is the way that the selector plate mounts onto it. It actually goes through inside of the gearbox. The anti-reversal latch is a little unusual, but I don't think that's going to be a big deal. But trying to shoehorn all the parts that we have into this particular design is probably going to be more trouble than it's worth. So what I've opted to do is go ahead and we're going to install a G&G gearbox, because I know that these have 100% compatibility with the parts that we're using. So let's get started on that. So if you've seen videos like this in the past, you know that I like to cut a little channel around the bottom of the gearbox to give the wires an area to pass through under where the motor fits in. In the past, I just used a Dremel in order to get to that, but what I'm doing these days is I've hooked up a milling jig where I'm using a milling vise. This is just a bench press with just a milling bit in it, that I'm just going to go ahead and cut a channel through this. So we just get the mill in there. This ends up being a lot quicker than trying to do it with the Dremel, where you've got to cut through it. It takes forever to do it that way. Where doing it with the Dremel or versus doing it with the drill press, I can actually cut through this much quicker, and it actually turns out much cleaner. So you don't have all of the skips and stuff that the Dremel tends to do. And you can see we have a nice little channel cut into there, so now the wires can run under where the pinion gear goes in, so it doesn't get worn away by that. It's one of the big problems with version 2 gearboxes, is that the wires and the pinion gear cross over each other there, and if you don't give it ample space, the pinion gear will actually cut through your wires and short you out, and then you won't be able to use it anymore. So you can use a Dremel to do it, but I found that the milling jig actually works a lot quicker. So getting back to our gearboxes, these compatibility issues that we were talking about earlier are probably one of the most common problems that people face when you're trying to do any kind of custom work on an airsoft gun. So if you're going out shopping for parts, it's important to know that your gun is compatible with like the Tokyo Marui standard dimensions and stuff like that. Most manufacturers usually keep within those standard dimensions. There are manufacturers that are out there that do not, and purposefully do not. Krytac is one of them. KWA is a prime example. Also, a lot of the Ares gearboxes are completely unique dimensions, and they're a freaking nightmare if you're trying to put custom parts into it. I suspect a lot of the manufacturers do it because you have to buy the parts specifically from them, and you can't go and just buy aftermarket parts. So if you're planning on trying to do something like this on your own, be prepared to do at least a little bit of homework to make sure that the parts that you've procured for your project are going to be compatible with what you're going to be putting them in. Next up with our build, we're going to install bushings into the gearbox. Now we're using steel. These are actually chrome moly 8mm steel bushings. You can see they're made by G&G, so I know they're going to fit with the G&G gearbox, so no compatibility issues there. The reason I'm going with steel rather than the standard bushings, G&G normally uses a bronze bushing. If you saw the Krytac gearbox earlier, these are ball bearings that are in here. These work fine. Either one of these work fine for standard builds where you're only running like a 16K motor. But as you get into higher performance motor and faster ratio gears, they'll burn those out pretty quickly. So you need something that's going to last longer. So we're going with the chrome moly steel bushings, and we're going to glue them into the sockets there so that they don't spin inside of it. The risk is that with most gearboxes, the shell is made out of a fairly soft aluminum alloy, so if your bushings spin around in there, it's just going to wear right through the aluminum, and then you're going to need to get a whole new gearbox shell. So we're going to take a little bit of glue, and we're going to glue each of them into there. It's best to get in there with a like a Q-tip, clean it out with some acetone. These are brand new, so we don't have to worry about degreasing them or anything, but if you're dealing with parts that may have grease on them, it's always a good idea to degrease everything thoroughly before you try to glue them in. And when you put them in, you want to make sure that they go flush. You don't want them to be on an angle, because then your gears are going to be sitting on a funny angle. So let's go ahead and do that. Reason I use a Q-tip when I'm doing this is so that I can just get the glue exactly where I need it, and I don't get a lot of excess in there. It's also a good idea to go ahead and remove any parts from the gearbox before you start messing around with glue, because if you've got like a selector plate or an anti-reversal latch or something in there, you don't want to glue that into place, because then it's not going to work. So just going to make sure everything sits flush in there. Everything's down where it should be. Might even give it a little tap. Make sure that it's flush in there. And then what I'm going to do is I'm going to hit it with a shot of the accelerant, which is going to make sure that that glue cures up nice and fast, so I don't have a bunch of extra glue in there. And then we're just going to wipe it down, make sure it's nice and clean. And that's pretty much what we're going for. So we'll just repeat the same thing on the other side. So the thing I like about the G&G MOSFETs is that they use a micro switch, which is designed specifically to retrofit the manual switch that was in there. The micro switch has got a very short pull to it, so you're able to get much quicker response than you can get with a standard trigger. And the other nice thing about the G&G brand is that these are a fraction of the cost of other MOSFETs that are out on the market. They're almost like a third of the cost, so it's much less expensive. We use these on our higher end rental guns, and we usually get about a good year out of them before they fail, and that's with a gun that's being used several times a week. So, you know, if you're not using your gun constantly, I'm sure you'll see the lifespan of it increase drastically from what we see, because our guns get the living crap beat out of them. So there's the micro switch. We're going to go ahead and start running the wires for it. There's a little, like a computer cable that goes into there that plugs in. It's got two unique ends. You can't put it in backwards. It only can go in one direction. So this is going to mount into here. And then there's like a little lip here. The wires are just going to route down under the lip, like so. That's what you're looking for, like that. And then they're going to route through here. So you want to get this kind of configuration. So next we're going to put in the wires that run to the motor. It's important to put these in at the right length. You don't want them to be too long or too short, so it's good to have an existing gearbox that you know that works as far as the length goes. So you're just going to sort of match it up to figure out what that length is going to be. I'll just put a little bend in it so I know that that's where this wire is going to be. So this is going to fit through here. I'm going to put it under everything since this wire crosses over. And then we're just going to run our black wire down through, and then we're going to run our data cable, or whatever you want to call it, back up through there. So this is all tucked in neatly. Having that cutout here allows you to run the wire out of the way, which it's also a problem having the wires stick up when you're trying to disable it. If you've ever been in the situation where you're trying to pull the motor out of the gearbox and the motor's like jammed in there, what happens a lot of time is that the gear on the motor is like this, and this edge gets caught on these wires, and that edge is trying to pull past those wires, and if it's pulling on the wires, it'll eventually just rip through the wires, and then you have to replace everything. So another reason why it's good to get them as flush as possible. I know some guys will get in there with like super glue and glue the wires in. That's a viable solution, although it's messy, and if you want to take them out later and reorient something, you've got a bit of more work because there's all this gunk in there, and you've got to get in with like a wire brush and clean it out. So I find this to be a little bit of a better solution because we're always having to do maintenance on our guns. Another thing I like about the G&G MOSFETs is they include these little metal clips that you can insert where the wires go back here that will hold them in place, so you don't have to worry about the wires constantly popping out on you. So you could just clamp it down in there, and now your wires are going to stay exactly where you set them, and they're not going to be popping out on you. Next thing we're going to do is some preliminary work on fixing the angle of engagement for this particular gun. Angle of engagement refers to the angle that the gear is at when it engages with the piston to start pulling it backwards. The way that most factory setups are is that the gear, the sector gear, grabs the piston in about the 1 o'clock position. It's not totally straight up. This is adequate if you're using standard gears and standard motors that are not running at high speed. But at high speed, you'll notice that the tooth of the gear is only making contact with like the bottom quarter of the piston. It's not fully engaged with the metal rack or the metal teeth that are on the bottom of the piston. What you want to do is have it fully engaged, not just engage the edge of the tooth. So what we're going to try to do is make it so that the gear engages with it in about the 12 o'clock position here, so that it's fully engaged with it in a flat configuration, so that it's getting the maximum amount of engagement with it. The problem is, if you're doing it like this, is that running at high speeds, it's really just grabbing the edge of it, and after so many, 100 or 1,000 shots, it'll eventually just wear away, and it'll just start skipping, and you'll just hear this bzzz, and it won't actually grab the teeth on it. So we're going to set it up so that it grabs it here. First thing we're going to do in order to achieve this is we're going to remove the first tooth on the sector gear, because we're starting the piston back a little ways. So if we use all of the teeth, what's going to happen is the piston is going to get jammed against the back. So we don't want to have as many teeth on there, otherwise your piston will jam against the back of the gearbox shell. So what we're going to do is take off the first tooth in order to lessen the amount that the gear is going to pull the piston back. The way that we're going to do this is we're just simply putting the gear in a vise, and we're just going to use an angle grinder, and we are going to just simply cut it to remove that first tooth off of there. You could also use a Dremel or a file, but you can see this goes pretty quickly with just using a regular old angle grinder, so you may want to consider that if you're doing this particular process. And that's pretty much it. Just want to chop that one tooth off. Just make sure you don't take off any teeth on the inside there, and stop short of the next tooth so that you're not damaging it. So So we're just going to take a metal file and just remove any sharp edges from it, and make sure that there's no bits of the old tooth left on there. And that's pretty much all you want. Now the other part with angle of engagement adjustment is to make sure that the piston is sitting in the correct spot. So in order to do that, what we're going to do is take the piston head off, and we're going to add some rubber to this to extend it out so that the piston does not go further into the cylinder. So in order to do that, we're going to take some neoprene here. This is, if you're curious what I'm using, this is about 1.3 millimeters. I usually double up on it, so it's about a 3 millimeter thickness that we're going to be using. I've just made a tool out of an old pipe that I sharpened an edge on it, so I can just take this and punch out the proper size thing. And we're essentially just making rubber washers, so we're just going to go ahead and punch those out. You see, we've got two rubber discs, and then you just want to put a hole in the middle of them. I just use an old conductor's punch to do that. So in order to punch the hole in the middle, I just use an old conductor's punch and just center it up on it and just punch the hole in it. Sometimes you got to take a couple of cracks at it to get it exactly centered. You can get points for neatness here, but just so long as you've got somewhere for the air to go through is really all you're concerned about. So we're going to glue these onto the back of the piston head in order to increase the size of it. Before I glue it, I'm just going to take a little bit of acetone and just clean off all the surfaces to make sure there's no grease on it. Clean these off with some acetone. If you're in a workshop like this where you've got a lot of silicone oil and stuff kicking around, it tends to get on everything. So if you want your bond to last, please make sure you clean it up real good before you try to glue it together. Acetone works really well. You could also probably get away with alcohol, although I find that acetone dissolves just about anything. So that usually works real nice to get them all cleaned up. So now that we're at this point, we're going to put a little bit of glue on them, and I'm just going to clamp it up for a little while, and we can work on some other stuff while the glue is setting. So we got them centered on there real nice, and then I'm just going to clamp them for a little bit until the glue sets, and then we're going to go ahead and install this. But it'll give us an opportunity to work on some other stuff while the glue is setting up on this. So next thing we're going to do is go ahead and install our gears into the gearbox. It's important to shim your gears properly. Everybody's got their own philosophy on it. My philosophy has actually changed recently, where I've been going with a little bit of a looser fitting shimming process. I'm finding that the looser shimming has less resistance to it. The tighter shimming, I'm finding, is causing the gears, or not the gears, but the motor to heat up a lot. They're blowing fuses, so a little bit of a looser fit seems to be working best for me. Now you could use whatever configuration works best for you, but right at this moment in time I am going with just 0.3 millimeter shims and leaving a little bit of play. Now this will probably vary from gearbox to gearbox because the internal dimensions of the gearboxes may be different. So we're going to go ahead and finish shimming these up, and we're going to go ahead and put in our anti-reversal latch. I'm using a little bit of grease. The grease that I'm using, this is just Danco silicone grease. You can get this at Lowe's or Home Depot. It's really designed for plumbing, so you can find it in the plumbing department. It's a heavier grease, so it doesn't splatter all over the place, and it works really well for me. I also put a little bit of grease, a dot inside of the rails where the piston moves, and a dot inside of where the tappet plate is going to be moving. So all I have to do at this point is just get myself an anti-reversal latch. So here's our anti-reversal latch, and the spring fits into here. This is all pre-greased up. We're going to go ahead, and we've added the shim onto it, so this is just going to drop into here. So that's pretty much our gears. What I'm going to do, I'm holding the anti-reversal latch down, I'm just rotating the gears over so that the teeth on the sector gear are on the bottom side of it, so that the piston can move inside of there. We're also going to add a dot of grease to the rails here and where the tappet plate moves, and I'll put a little dot of grease on the top of each of the gears here. I went around the teeth of the gears with some grease to make sure that they stay nice and greased up. So just go around the outer ring of them, of all three gears, and make sure those stay nice and lubricated. And we can start working on putting our piston back together. So we're going to go ahead and install our piston head inside of our piston. You'll notice that this is a full metal rack piston rather than a plastic or nylon rack piston. So this has all metal teeth, so it's going to last longer. For lower speed standard builds, these regular pistons with the plastic teeth work just fine. For high speed builds running at higher speeds, it'll generally wear those out a lot faster. So you want to go with the metal teeth, and you want to take out the first tooth. If there is a first tooth, if you don't see a gap there, what you want to do is grind that first tooth out. Otherwise they tend to bind there. So you want to take that out, reinstall your rack, and then you can go ahead and start putting the piston back together. So now you can see we've got our piston head all glued up. We've got the extra neoprene rubber bumper on there to push the piston back in further. So when we assemble this, we should notice that when this is sitting here, it's in about the 12 o'clock position. So when this gear comes around to grab the first tooth on there, it's meeting it. There's more metal meeting the metal. Otherwise, if it's meeting it way back here, it's just grabbing the edge of it. So that's the whole reason why we go for this particular modification. It was really perplexing with me when I first started dealing with this, was that you would get this sound like the gear was just skipping over the teeth on the piston, and it just was not making good contact. And it turns out that was all because the angle of engagement was off. For standard builds, not necessary, but for high-speed builds like this, it's absolutely necessary to get that set up properly so that it does not skip on you. Next thing we're going to do is install the trigger and the speed trigger adapter onto it. The ETU MOSFET for G&G comes with a special trigger that has a spring style paddle on it, which is what makes contact with the button so that it doesn't beat the crap out of the button. If you want to get better trigger performance, what you're going to need is something that takes up the space, because when this trigger is in there, it has about, what's that, about 1/4 of an inch of movement. We want to take that play out of it. So what we're going to do is we're going to replace this spring with this little plastic doohickey that AirTech Studios makes that allows us to make this operate as a speed trigger, and you get much faster response out of it, which you will see shortly. So we've removed the spring. And I'm going to go ahead and save the old spring because on our rental guns, people mash the crap out of these, and these eventually start to bend and they don't work anymore. So that's one little extra part that I like to keep in reserve. It's something you probably never need to worry about, but for here, where people wear the crap out of our stuff, we generally like to keep spares as much as possible. So it comes with special screws to attach this. This essentially is just going to mount onto the trigger in place of the spring. And it has these little screws that need to fit into here. Half the work is just getting it lined up on there. And then you can screw these in. I'm just going to get the one started and then put the other one in so it's all lined up. If you've got smaller fingers, you might have a bit of an advantage with working on these, but we're just going to go ahead and screw this all down. So now that is on there, and this little paddle that sticks out, that is what is going to press against the little micro switch in there. So now you can see there's almost no give to it. It's only maybe a 32nd of an inch movement versus where it had about a 1/4 of an inch of movement. So this is going to make your trigger way more responsive. So all we got to do is put our spring in there from our old trigger. Don't forget to install your selector plate and make sure you put in the proper plate. When you purchase an ETU, it will come with a modified selector plate. Your standard one that will come with your normal gearbox will have this extra tab here. The ETU version will not have that tab, so make sure that it is the one that is tabless that'll fit into here like that, and then you want to go ahead and install your safety. It's easier to install the selector plate if you do it before you put the safety in. All right, at this point we can go ahead and button it up. We've got the spring guide, the tappet plate spring, the speed trigger is installed, all the wiring is in. We're ready to go ahead and button this thing together. So go ahead and compress our spring. This is the most nerve-wracking part, is putting the final cover back on it, because if you do everything right, it just all falls right into place the way you want it. Sometimes things don't always cooperate on the first try. I've had a few times where it takes multiple tries to get it all the way assembled. And before I start putting screws on it, I like to make sure that the piston is moving, the trigger is moving, the tappet plate is moving. So just make sure you got all three of those before you put screws in it. Otherwise, if you start screwing it together and then you notice that things are not meshing up properly, it could be a giant pain in the neck. So get those things straightened out first before you start buttoning it all the way up. And what I generally like to do is just get at least one screw started in there, and then I can take my finger off of it. Once you've got at least one screw in there, you can start to breathe again, because it's not going to just fly apart at that point. So at this point, we're going to go ahead and get it all put back together. And if you're using an electronic screwdriver like I am, use the lowest torque setting, because you do not want to strip out these screws. And that is that. So there it is. We're pretty much ready to give it a try to make sure that our electronics are working properly. I like to go ahead and just do a dry run before I install this into the receiver. Reason is, if there's something that's not wired in properly, it's easier at this point to go ahead and correct the problem and then reassemble it, rather than having to take it all apart from the receiver and then reinstall it. So let's give it a dry run make sure that we get a heartbeat out of this thing, and we'll go from there. There it goes, doing exactly what it's supposed to do. One other thing I'm going to do is replace the Tamiya connector with the Dean's connector. I find that these higher speed motors tend to run at higher amperages, and I've seen these melt to the point where they fuse together and you can't even get them apart. So it's a good idea to go ahead and upgrade your Tamiya connector to a Dean's connector when you're running a high-speed build like this. So I went ahead and tested it, chronographed it, make sure that everything was working properly. We're getting an average of around 300 feet per second, which is great for indoor use. Obviously, if you're going to be playing outdoors, you might want to get a little bit of a hotter velocity out of this. But for doing what we're doing, getting super high performance and very, very fast trigger response, if you put in heavier springs, it's going to slow that down somewhat. So there's always going to be a little bit of a compromise between whether you want to have a gun that has a higher velocity or a higher, quicker trigger performance. So you'll have to make that decision as you're speccing out your gun. So if you want more information on setting up one of these builds, just get in touch with us. You can either stop into the arena or send us an email, whatever, text, and we'll see what we can do about So if you're interested in doing, God damn it. So if you're interested in doing one of these builds, just contact us, either stop into the arena or drop us a line, and we'll be glad to sit down with you and spec out a build that works just for you. So till the next time, don't let the bastards get you down.